All right, if you're going to solve this using either Gaussian elimination or F-stored elimination, the first thing that you want to do is put this into an augmented matrix. So I'm going to put 1, 2, 8, draw my line 0. Then the next row will be 2, 5, 18. And then last row will be -5, -8, -36, -12. So this is the matrix that we're going to be working with. And so remember, our goal is for just doing Gaussian elimination is a 1 with zeros below, and then a 1 with a 0 below, and then a 1. And then the other entries are just some number. So again, that's just using Gaussian elimination. So what's nice right here is I already have a 1, so I just need to make these turn into zeros. So starting with the number 2, if I want that 2 to turn into a 0, I'm going to use the 1. So it's really nice if you can make the 1 in the column first. So if I take row 1 and multiply it by a -2, since -2 would cancel out with +2, and then add that to row 2, that would make my new row 2. So I'm going to show my work right here. What that means, if I multiply row 1 by -2, I get -2, -4, -16, 0. And my row 2 is still the 2, 5, 18, -6. And so when I add those together, I get the 0 I wanted, and then I'll have a 1, +2, and -6. So this is my new row 2. So the only thing that's going to change in my matrix is going to be that row 2. So you can see I just left everything else the same. There you go. So then I want to work on getting rid of the -5 there. So to make that go away, I'm going to multiply again that 1 by what would make a -5 cancel. That would be a +5. So I'm going to take 5 times row 1, add that to this row 3, and that will make my new row 3. So showing my work, 5 times row 1 is going to be a 5, 10, 40, 0. And my row 3 is still -5, -8, -36, -12. So when I combine those together, my new row 3 will be 0, 2, 4, and -12. So again, let's see, I'm going to write row 1 and row 2 the same, because the only row that changed is row 3. So even though I used row 1, I only changed row 3. So it's really important that you write down the row operations that you did to show me each of these steps here. So my row 3 is 0, 2, 4, -12. So now when we go back to thinking about this Gaussian elimination, we have our 1 with our zeros below. And for our next column, we need a 1 in the middle and a 0. Yay, we already have a 1. So then we just need to make the 2 become a 0. So to make 2 cancel out, we need -2. So now I'm going to use this row 2, where that 1 was. I'm going to multiply it by a -2 and add that to row 3 to make my new row 3. So -2 times row 2 will be 0, -2, -4, 12. And my bottom row will be 0, 2, 4, -12. So when I combine these together, I get 0, 0, 0. Ooh, lots of zeros. So I have zeros all inside that last row. So that's 1, 2, 8, 0, 1, oopsie. Got 0, 1, 2, -6, and the last row is all zeros. So remember what that means, if that last row is all zeros, that we have infinite solutions. And so what we might want to do is say what they look like. And so the way that it's set up for your solution for Alex is that if you hit the infinite solutions, then you have to say what they look like. And it gives it to you like this. And really what it wants you to do is write an ordered triplet where you have Z as the last guy and your X and your Y are written in terms of Z. So if I go back up here and write the equations that are left, that's X plus 2Y plus 8Z equals 0, and I have Y plus 2Z equals -6. And then 0 equals 0, which let me know that there's infinite solutions. So when I kind of work my way up, and I look at this y plus 2z equals -6, I can rewrite that so that way it's y equals something. And I do that by subtracting the 2z, so subtract 2z. So y is equal to -2z minus 6. So what I just did is I wrote y as an expression that just had z's in it. So my y will be -2y minus 6, and I didn't leave myself enough room for that. So now you do the same thing for x. So if I look at what's going on in that first equation, if I get x alone, I'm going to have x is equal to, well, minus 2y minus 8z minus 2y minus 8z. And I want it all in terms of z. So I'm going to use the y I just found and plug that in here. So that way I'll only have z's. So that would look like x equals -2 times -2z minus 6, because that's an expression that represents my y. So then simplifying this, it looks like x will be equal to, that'll be a positive 4z, a positive 12, and then minus 8z. Collecting like terms, it looks like x should equal 4z, and -8z will make -4z plus 12. So that's my x written in terms of z. So then I would go and write that down in here, -4z plus 12. So written a little bit bigger. When my x is written as -4z plus 12, my y is written as -2y minus 6. Oops. Actually, I'm going to go back on that. Oops. That should have been -2z minus 6. So sorry about that. And I'm going to go over here then, rewrite this. So it'll be 2z minus 6, and then z is any real number. And so that's what all the ordered pairs are going to look like. So when we say infinite solutions, it's not anything, but it's particular ordered pairs that satisfy all three. And this is what they're going to look like, where z is any real number. So hope that was helpful.